This call is now being recorded.
Okay. Assalamualaikum warahmatullahi wabarakatuh. We meet again in this international class of Programmable Logic Controller. And for today, we'll discuss about two different systems that can be controlled using the PLC. The first system is the box level inspection. So we can see it here that there are three different conveyor, which means that, of course, those conveyors will act as outputs. Yeah. So never mistake between the input or the output. And we already know that there are some definitions here. Push button start as PLC input, push button stop as also PLC input. So we can just define the address for those inputs. Okay. So maybe it will be easier if we can just write the input here. Okay, this is the PB start. And, okay, so we can just give the address here as usual. Maybe it will be better if I give this as percent I 0.0. Okay, as the PB start and the PB stop. It will be okay. Sorry, excuse me. Okay, so for the PB stop, it will be percent I 0.1. Okay, so we have two input here. We can define orders as well, but we can see it here that the conveyor one drive the motor as PLC output to drive the box to the label checking section. So we can see it here. This is the conveyor one, and it will make the box to move to the check inspection. Okay. Okay, so the conveyor one we can treat as an output. Sorry, excuse me. This is the percent Q 0.0. Okay, so this is the conveyor one, 2% Q 0.1 and the conveyor 3%. I'm sorry. Percent Q 0.2. Okay, so we already defined all the conveyor here as the output, and we already give all the conveyor the address. Okay, so we can see it here that the system will be like this. When we press the push button start, the conveyors will be active, and the conveyor one will bring the box to the section of label checking here. You can see it here. And the box will be monitored and will be detected using the sensor to check whether the label is in the right position or not. And if the label is in the right position, it will move to the conveyor 2. And if the box is rejected, it will move to the conveyor 3. So the situation will be like this. There is a box and the conveyor one will move the box into or inside this label checking section. If the position of the label is right, if there's nothing wrong with that, then it will move to the conveyor too. But if there is something wrong with the label, or which means that the sensor cannot detect the position of the label, the pusher here will be active and it will push the box to the conveyor tree here. So I think this is a very straightforward situation and it is easy to imagine. Okay, so what is the meaning of the label in its position? Okay, so because we can read it here that the photo detector switch will detect the position of the label that has been installed on the box using the photo detector switch S2 and S3. There is also the photo detector switch S1 to detect the position of the box, which means that when the box is already detected by the sensor photodetector 1, the conveyor 1 will be stopped. And this is an additional situation that must be met in order to make the system work. Photodetector 2 and 3 must be active after photodetector 1 detects an object within 5 seconds. If after that the S2 and S3 are still inactive, the box will be rejected. So no matter what the situation is, after 5 seconds and the S2 and S3 still detect nothing, the box will be rejected. And there is also other sensor as well. The proximity switch S5 to to trigger the rejected box counter, and the proximity switch S4 to trigger the received box counter, and the proximity switch to limit the motion of the driving motor when advancing, and also the proximity switch to limit the motion of the driving motor when reversed. So we can see it here, S6, S7, S2, S3, S4, S5, and S1. S1 will be located here. Okay. So we have to define all of the sensor there. Okay, S1 percent I0.2, S2 percent I0.3, S3 percent I0.4. I don't know whether this is sufficient or not. S4 I0.5, S5 percent I0.6, S6. percent I0.7 and S7 here, percent I0.8. Yeah, I think this is sufficient because we have 9 input address here. Okay. And of course the pusher. Okay, the pusher here, percent Q 0.3. Okay, so we can see it here that this is our situation here. We already defined all of the input. Okay. Okay. So we start our work right now. We use our usual PLC here. Okay. And run as usual. Percent I0.0 SPB start to start it all. And we can just make something work here. Okay, we can start it by make it this configure active. Configure 1. Okay, so this is how to make the configure 1 work. And of course, after that, it will stop the configure 1 after the photo switch 1 or S1 is detected. And we can see here the S1 address will be percent I0.2. Okay, and then it will reset the configure, which means that of course the configure must be stopped. Configure 1 in this case. Okay, Q0.0. And then there are two possibilities. The first one is that the S2 and S3 will be active, which means that the label is in the right position. And if that happens, then the conveyor will work and the box will move to the conveyor 2. But if in this case the sensor 2 and the sensor 3 didn't detect anything, it means that the location of the label is in the wrong position, which means that the pusher will work to push the box to the conveyor 3. Okay, so in this case, both S2 and S3 must be active at the same time. And we already know from the statement in the assignment that in this case, it must be detected within 5 seconds. So we create the timer first, okay, which will be activated by the activation of I0.2. Okay, this is the box sensor, or maybe S1. Yeah, S1 here. Okay. And we want to activate the timer here. Sorry. Okay. And of course, within 5 seconds, it will be easier if we use the pulse timer. Okay. So we give the address for the pulse timer. M0.Q, and then this is the S2 and S3. I0.3 and I0.4. You can see here 0.3 and 0.4 to detect the label, which means that in this situation, the conveyor 1 will work. Maybe it will be better if we activate something here. Using the address of M1 or M0 here. And of course, we can make it parallel. Because we don't want to make so many different output here. Okay. So in this case, we can see that the situation will be like this. When we press the push button, the conveyor 1 will be active, and then after the box move, it will be detected by sensor 1 in its right position, and the conveyor will be stopped. And during the time, within 5 seconds here, if both sensor, which in this case S2 and S3, detected the label, yes, it will activate the M0, and the activation of M0 will make the conveyor active again. And of course, in this case, the conveyor 2 will be active. We can see it here, the conveyor 2, which is activated by the S4 here. We can see it in here position. S4 is the sensor that make the conveyor 2 active, because when the conveyor 1 is activated again, it will automatically push the box to the conveyor 2, and after the box arrive at the conveyor 2, it will be detected by the S4 sensor, and in this situation, the conveyor 2 will be active. Okay. You can see it here, S4. Okay, version A0.5. Conveyor 2. Don't forget to use set here. Q0.1 conveyor to. And it will be stopped again after a certain situation. And then we have to see other angle, which is when the one of the sensor or both sensor is inactive. Okay. So actually we can make it simple. Uh, 0.2 here. It will wait until 5 seconds. And we use different timer. And in this case, it will be more suitable if you use the on delay timer. 5 seconds. Okay. So if after 5 seconds the M0 is still not active, it means that a certain situation occur. Okay. It will make the pusher active. Okay, so the pusher will be in S7 position and it will active until the position is checked by the S6. Okay, S7 and S6 actually define uh, the position of the proximity of the driving motor or the pusher. You can see driving motor or pusher here. S7 here. Okay, I0.8. And it will activate the pusher percent Q0.3. and the pusher will be stop activate when the the sensor S6 is active. I'm sorry, this is the wrong address. 0.7 S6. Yeah. And it will push the box to the conveyor 3, and we can see it here that in the conveyor 3 the box will be detected by sensor 5 or percent I0.6. S5 and conveyor 3. And then conveyor 2 and conveyor 3 will be stopped when the sensor 1 is active. So it will still working until sensor 1 is active. A0.2. Okay, and it will reset conveyor 2 and conveyor 2, conveyor 3. 0.1. Key 0.2. And of course, we also have push button stop to reset. We can just put it here. I0.1. Push button stop. And we also make the conveyor 1 to stop. I0.1. So from the very beginning again, when we push the PB start, the conveyor 1 will be active. The S1 will be active, which means that box already inside the checking area. When the push button, or sorry, S1 is active, it will also make conveyor 2 and conveyor 3 inactive, because we don't want to waste our energy or electricity to those conveyor. because in that situation, we assume that there's nothing above those conveyor, so it must be stopped. Okay, so when the box is detected by the S1, the conveyor 1 will be stopped, and at the same time, the timer will count. We have to use two different timer here. The first one is the timer pulse to make sure that the S2 and S3 here is working within 5 seconds. So within 5 seconds, if both sensor working, it means that the label is detected. And in that situation, M0 will be active. What this means, the conveyor 1 will be active again. And of course, we can see it here that when the conveyor 1 is active again, the box will leave the conveyor 1 to the conveyor 2. Okay. It will leave the conveyor 1 to the conveyor 2. And during that time, we can see that I0.5, I'm sorry, we have to give this label S4. S4 will be active. Okay. The activation of S4 will make the conveyor 2 to work. Okay, so in this situation, it is assumed that both sensor S2 and S3 are active, which means that the label are in its position. There's nothing wrong with the label. There's nothing wrong with the box. But what happens after 5 seconds and there is nothing happen here, which means that the opposite happened. There's something wrong with the label. Maybe the position is not right. Even though one of the sensor is detected the label, if both sensor are not detected the label, it means that the label is not in its right position. In which case, we already count the timer 1 after 5 seconds, yeah, after 5 seconds, and uh, the situation doesn't occur, which means that both sensor not detecting anything, it will still remain as normally closed. We can see it here that M0 will be active when both sensor is active. But if it is not active after 5 seconds, it will still remain normally closed. And of course, S7 will detect the pusher in its minimum position, so it will be active. The pusher will be active, but after the pusher move to its maximum position, it will active and it will close again. Okay, and then during that time, the box will move to the conveyor 3 and it will be detected by the S5. And of course, when the S5 detected there is a box, the conveyor T will be active. Okay, so it will still remain active until both condition, whether the PB stop active or I0.2 is active. And everything will be repeated in the same situation again. Okay, because the conveyor is already active again. We can see it here that the conveyor 1 will active after M0 is active. So this is how we solve the first problem here, the inspection checking system. It is not that difficult, to be honest, but we have to be careful here. Okay, inspection label. Okay, so next we will move to our second problem, which is maybe not that difficult. We want to, liquid filling system in cans. And we can see it here that there is a can here. Have to make okay, can. Okay, this is the solenoid, sensor level X3, and then lamp indicator, run, standby, and full, and conveyor, photosensor. So the system will work something like this. Empty cans. This is the empty can assumed to be on the conveyor, and the conveyor will be active. Yes. And deliver to the filling station here. The photosensor will detect the can. When the can is in the right position, the solenoid will be active until it is detected by the sensor level. If the liquid level has reached the proper level, the setting level, the sensor level will be active. Okay, and then of course the solenoid will be stopped because we don't want to make the liquids fall to the conveyor. So after the sensor level is active, the solenoid will be inactive and the motor conveyor will active again, and it will be repeated something like that continuously. Okay, so this is the second situation. The run indicator shows that the process is in progress, and this indicator will be active when the input start is pressed and will turn off when the stop is pressed. So we have to define our address first. The standby indicator will be active when the system is resting or there is no process. So this is the opposite of run, and the full indicator will only activate when the liquid level has reached the desired level, which in this case when the level sensor is active, and turn off again as soon as the can leaves the filling station. So we have to make a program based on the situation. So it will be very wise to do to just define the I/O as usual. Okay. So we can see it here that there is no start and stop button. Yeah. There is no stop and start button. I'm sorry. There is start and stop button. Yeah, my mistake. So the conveyor will work when the start is activated. So we can just set here %I0.0, and then of course the stop button %I0.1. And then okay, maybe we can just define the output first, the run %Q0.0, and then standby %Q0.1, and full %Q. I'm sorry. Okay. So for %Q0.2, it is up to us. Okay. And we can see it there as photosensor, level sensor first. I'm sorry, version I0.2 photo sensor, version I0.3, and then the solenoid here, version Q0.3. So we don't have to follow the number that are already defined. We can just make it as the address that we really want here. Okay, is everything here. Okay, we can imagine that when the push button or start is pressed, the conveyor will active, and then of course the run will also active. Okay, so standby means that there's nothing active. Okay, so when we press the start, it means that the run will active, the conveyor will active, then the can will move until it arrives at photosensor, and during that time the solenoid will active, and it will fill the can with the liquid until the sensor lecture is active. During the time the solenoid valve will be disactive again, will be inactive again, and then the motor conveyor will off again. Okay, so during you know during we when the liquid is full, the output full will active, and it only happen maybe in the very short amount of time. Okay, so yeah, it will be easy if we start it from the scratch. Okay, we start by using the start I0.0 to activate the conveyor. Okay, I actually forget to give the conveyor here, Q0.4. Okay, this is the start, and it sorry. Oh, it cannot be start. So okay. Okay, so the address start is prohibited. Okay, and then this is the Q0.4, and this is the conveyor. And then we go to the next run. But we already know that when we press the start, the run lamp will be also be active. We can see the address here, Q0.0. I'm sorry, this is mistake. We want to make it simple here. Q0.0 run. I hope it is okay. Okay, run. And then the conveyor will work. The can will move until it arrives at the photosensor. So it is basically very easy, I guess. I0.3 photo sensor, and then the conveyor will stop. And then the solenoid valve, okay, Q0.3 will active. Okay, this one will be active, the conveyor will stop, yeah, until the level sensor is active. You can see it here, level sensor I0.2. I0.2 here. This is the level sensor. And we can see it here that when the level sensor is active, the solenoid will also inactive. The run, I'm sorry, uh, the full lamp will active key 0.2, but we don't want to make it as set. So it will be active in the very short amount of time. And then the conveyor will run again. Okay, I0.2. Okay, it will make the conveyor run again. And of course, we have to create the standby lamp. The standby lamp will always in the posit situation of the run lamp. So we can just make it something like this. Q0.0. And this is for the standby key 0.1. Maybe it will be better if we use the normal. Yes. Okay, this is the standby situation here. So this is always the opposite of run. When the run is active, the standby will be inactive. If there is not active here, the standby will be active. Okay, and then the stop uh, the conveyor. The stop here. I0.1. Okay, but we want to avoid the situation when uh, okay, so maybe it will be better if we make different input here. Why? Because when we want to make stop button, we don't want to make the solenoid active. So the solenoid must be in the separate. Uh, this is solenoid. And after that we delete the why? Because we want to make the conveyor stop. But if we put the solenoid address in the same run, it will also make the solenoid active. It is something that we want to avoid. Okay, so we delete this. Be careful, because sometimes it can be very annoying to just delete so many lines here. Okay, and then the stop button 0.1 if I was mistaken. And this is the stop. Okay, the stop button will make the conveyor stop, and it also make the standby button here. Or we reset the run. Okay, stop. Like I said previously, everything that is set must be able to be resetted as well. So you have to make sure that there is a address to make something that is already set to be resetted. This is the Q0 dot. I'm sorry, I forget. 0. So if we want to start from the very beginning again, when we press the push button, start here, in this case, the conveyor will active. Okay, and then after the can is moving, the photo sensor will detect the can, the conveyor will stop, and then it will make the solenoid active. It will stay active until the level sensor is activated, and then the solenoid will be inactive, and during that time the full lamp will be active, albeit it is in the very short amount of time, and then it will make the conveyor start again. Yeah, it will make the conveyor start again, and it will be repeated. Okay, if we press the stop button, it will reset the run, and during the time the standby will be active. Okay, so this is the second assignment. I hope that you all understand this, and after this you will grasp the idea about the automation system that usually work using the PLC. There are many systems out there that can be applied by the PLC, especially for the control system. And we only learn here about the digital aspect of the system, because if we want to merge or make combine the digital and analog input and output, it will be too difficult. So I just want to make it very simple using daily system that can be easily understood, and I hope that you all understand it. Okay, so this for our lecture today, and I will give you the assignment, and I hope that you understand the assignment here. So this is about the dove, okay, how to create the dove here. We can see it here that there are many different system input and output here. To start the process, you have to press the start push button, and then the palm eye and the indicator lamp A, it will be active. Palm B and lamp B is also active, and the mixing mixer will mixing the dough in the tank, and the lamp mix lamp will work. On the other hand, the conveyor A will also active and pour the concentrate into the tank. And after the completion of the filling and stirring process, followed by the second step, which is the activation of the pump C and line 1. When the photoelectric sensor S2 is blocked by the can, it will cause line 1 to stop, and the solenoid cell A opens the valve, the lamp cell A indicates lines turn on, and the liquid is filled into the can. As a result of this filling, the amount of paint mixture in the tank will be reduced, and once the process is continued until the liquid level is in the tank touch the low level sensor. If this happens, the system will automatically return to step 1. And for the step 3, when the can containing paint reaches its maximum point, it will be grabbed. This not is grabbed and taken to the conveyor containing the box. Also order the motor to move forward and only stop after the limit switch is touched, which is right above the cardboard. And after reaching the top of the box, the can will be dropped and then carried by the cardboard in line 2. And we can see in line 2 works when the gripper moves, the cans fill with the paint from the line on 1 to line 2, and this conveyor or line is in charge of carrying the cardboard needed as containers for filled paint cans. When we can use the safety sensors, for example, the high level sensor, which are installed to detect the height of the dove, and if the level exceeds the threshold, the system will automatically shut down. The stop push button can be activated, but the execution results will only appear when one cycle has been completed, or in this case is the dot level is low. So we can see it here that the system requires a lot of input and output. We can see based on the table here, maybe we cannot use the usual PLC, in this case CE16R, because in that type of PLC, we only have 9 input or and also 7 output. We have to use maybe different type of PLC, something that has more I/O. Maybe we can use TM221 CE4TR. Okay, so you don't have to use this type of PLC. You can use this type of PLC, which is more suitable for the system, because the system has large address. I mean, has a lot of address, has many address as input or as output. So you have to be careful here. And we can see it here. This is the palm A, this is the steering, the low sensor, high sensor. This is the conveyor A, conveyor B, and conveyor C. This is the can, this is the box. And this is the indicator, start, stop, and buzzer. So your task here is to create the system in order to make the automation work. Okay, I hope that you all enjoy this. I hope that you all understand this. So the assignment, the due date will be next week. And next week, we will meet again. And before the final exam, there is also a quiz. Okay. Okay. So I think this is concluded our meeting today. I hope that you all enjoy it. Assalamualaikum warahmatullahi wabarakatuh.